A matrix is a rectangular array of numbers enclosed in brackets. It is a useful way to organize data. Each matrix has specific dimensions based on how many columns and rows it has. Each value in a matrix is called an entry. The location of an entry is its address. It is represented by the lowercase matrix letter and the column and row numbers as the subscripts. To add two matrices, they need to have the same dimensions. Scalar multiplication is when you multiply an entire matrix by one number. Multiplying matrices. Multiplying two or more matrices is a matrix product. A matrix can only be multiplied if the number of columns in matrix A equal the number of rows in matrix B. To multiply two matrices, you multiply the first row in matrix A by the first column in matrix B. A square matrix is any matrix that has the same number of rows as columns. When using matrices to transform geometric figures, you multiply the x and y coordinates by the translation matrix, like the ones below. A determinant is the difference of the diagonals of a matrix. Cramer's rule. Cramer's rule is a formula that solves a system of linear equations. Cramer's rule uses determinants of the coefficient matrix to find the solution to the equation. Matrix inverses. A matrix can have an inverse only if it is a square matrix, but not all matrices have inverses. If the product of a square matrix and the inverse matrix resolves in an identity matrix, then the matrix is called a multiplicative inverse matrix. But how do matrices apply to the real world? This is the question that stumped me. I always thought that the math that we learned in school never applied to real-life situations, but after extensive research, I was proven wrong. Matrices in general provide a useful way to organize any data, but I found that it can solve electrical network problems, it helps with scheduling such as flights or shipping schedules, and many other things. One unique thing that I did find as well was that CAT scans solve linear equations to create the image. Matrices also play a part in developing an approach. It developed an approach to quantum mechanics. Matrices was one of the many things that we learned about this try that I enjoyed, and hopefully I can take into other classes, into real-world situations. So I'd just like to say thank you for teaching me, and I really enjoy this class.